Good morning. I'm Sean. I'm with the Center for eResearch at the University of Auckland. And here to talk about Nectar in New Zealand, 7 years and a bit. It's been between 7 and 8 years, depending upon where you mark the start. It's kind of 7 years since we really had the first researchers on board, so I kind of called it 7 years. And I was just kind of looking back. It seems like you always romanticize things in the past, and then I started looking at what were the news headlines, what was going on in 7 or 8 years ago, and realized that things aren't always as great as you remember them. So some things haven't changed, but one thing that has changed is research computing, and leaps and bounds. When we started, Nectar started talking about it in 2016, started implementing it in early 2017. There really wasn't a great solution, at least at University of Auckland, for interactive mid-tier compute. By mid-tier, it's that middle ground in between your laptop, or possibly a virtual desktop or something, and HPC. There were also a lot more drivers in research for more interactive workflows, or pre-preparation of code or something before submitting to HPC. So it was a bit of a gap. And the solution for a lot of researchers, at least at University of Auckland, but I suspect in other places, is the server under the desk. And this wasn't a great option for all the reasons that we know about. They're not patched or maintained. It's shadow IT, and the one researcher that was looking after it that's technical leaves, and then it's, who's looking after it. And it's very duplicated, right? It's not very collaborative or reproducible. And then, so we looked towards the university for solutions. There was in our case, there was a VMware farm, and we were offered to a service where we could give researchers VMs that were hosted by the corporate ITS at University of Auckland, and it really wasn't ideal. I mean, it worked, but it was like months of lead time and really process heavy. It was more for setting up production level resources instead of kind of short to medium term research solutions. Somebody wants to run some Python code or something, rather than a long-term ITIL service. And of course, security has grown. There's a talk on that that I'm co-hosting at 2:20, I believe, with Tom, who's in the audience, I think. So more detail on that, but I think we can all agree that in 2016, 2017, there wasn't a whole lot of, especially in the research sector, wasn't a whole lot of emphasis on security. And now, due to reputational risk and it's just a different world now. That the attacks are more sophisticated, and there's a lot more risk. So that's changed a lot. So what started it all? Actually, at eResearch, NZ 2017 in Queenstown. That's probably too small to read. I'm sure it is, but. And I'm not sure what that kangaroo is shaking with the kiwi. It's not his hand. But ministers from MB and from Australia, counterparts, set an agreement for collaboration and research, working with one another, and that paved the way for Nectar. So Nectar, I looked up in the database, and the very first instance or VM on OpenStack was launched at 2:28 p.m. July 6, 2017. So I thought that was pretty cool that there was actually an exact time when it kind of came to life. So it took a while to set up. We kind of set up the base infrastructure, and then core services then came over from Nectar in Melbourne. They came over and they kind of helped set up Puppet and get the services running and everything. And OpenStack's pretty complicated, so it took a little while to iron out some of the bugs and everything. But so we kind of started piloting in Q3, and then we kind of went into soft production. It's not really a term anymore, I know, but it was then getting real researchers on in 2018. First GPUs, we got a GPU node with some business case money that we found in 2018, 4 K40s, right? It seemed like a lot at the time. And it was fairly modest when we started out. It was just a few kind of commodity compute nodes, nothing super high performant or no SSD or anything like that. But it was enough to kind of get us started. In 2019, Nessie decommissioned the PAN cluster, HPC cluster, and I think it was just meant to go to the scrapyard, so they were very generous. We were able to, because OpenStack is such a such a heterogeneous platform, an open platform, we're able to incorporate at least the latest trench of the PAN nodes, the Ivy Bridge nodes, into Nectar. And that really gave us a huge amount of capability and resilience as well. So who's in the Federation? I won't overlap too much on what Bernard's talk did excellently, but I'll just quickly say that it's universities and groups of universities across Australia, and then little old University of Auckland. So they're adding a couple more this year. University of Adelaide, Palsy Supercomputing, they used to be a node in Nectar, and now they're coming back. And then they're setting up an RNet national node in Sydney, I think to, and Bernard can correct me, for more kind of production workloads that need, really dedicated uptime and other national projects. So why open infrastructure? Why not just go to the public cloud, right? Open source software is really, as we know, really close to research and researchers and research workflows. The tools that it runs on are open source: Linux, KVM, Docker, Kubernetes, Puppet. There's no licensing. It's very open. They're collaborative. It just works. The heterogeneous scale out, like I said, you can get old hardware and new hardware and kind of ring fence them off and use them for different use cases. And we've got a situation now where we're offboarding off of some old VMs from that VMware at University of Auckland because the servers are perfectly fine, but they're just incompatible with the latest version of ESX of VMware. So, in this case, we don't have that kind of hard cutoff for things. That can be a disadvantage as well, because sometimes, like, why don't you just use this old stuff instead of getting some new stuff, It's still, it's really hard to quantify cost with cloud resources. You can do it many different ways, and it's hard. But I think the consensus is that at a certain scale, on-prem cloud is still more cost-effective than public cloud. I think we saw a huge shift to the public cloud, and then when people realized that they actually needed like financial operators to do the calculations and the cost overruns were huge, then there was kind of a retreat, and now they're looking at a kind of a hybrid model, or maybe on-prem is the way to go in some things. So just a very high level of the architecture. I got the rasterized version of the slides, so I couldn't. I'm just covering up an area for later. But so basically, it's like a hub and spoke architecture where a lot of the core services, like the Horizon dashboard, which is your web dashboard that you interact with, the main API endpoints, and some of the central databases and rabbit queues are hosted in University of Melbourne at the central node. And then it's federated off, and there's cells or nodes at around the federation, and then they run a subset of the services. And the storage is node specific. So you kind of bring your own storage, whatever that is. It could be university-backed storage that's connected in. It could be Ceph. It could be whatever you'd like it, local storage on local disks. You can run pretty much anything, and all these tools are available on OpenStack right now. There's new tools being added every day, it's whatever you want it to be, really. There's really not many limitations. So how successful has it been? So since late 2017, when we first got the first projects on board, there's been 687 total projects. And then the below, I'm not sure how readable it is, but this is the churn of new projects, new allocations for the month, I believe. So it looks steady. You can see the steadiness here as well. This is total instances, or VMs, that are launched. So we got about just under 500. This number changes around all the time, of course, but this is just kind of a moment in time. And then used vCPUs. This is a total of, you can oversubscribe, of course, with cloud. So this is the total number of vCPUs. One thing, sometimes it looks like it's plateauing, but something to keep in mind is the reason that it's plateauing is because the service is really, really good at reusing and recycling stale infrastructure. So there's an automated offboarding process where if you're not using your resource, you get notified by plenty of emails and communication. And if you've left the university or you don't need it anymore, you can obviously reply, or if you don't, then all the resources are shelved and kind of archived for a period of time, and then they're removed. And it really takes, that's a really hard thing we found with research workloads is offloading them. You know, it's really hard to delete things, right? This is just to give some sense of scale. You won't be able to look too closely on it, but you can go to the status.rc.nectar.org.au and actually look at this yourselves. But it just kind of gives you a scale that, you know, it looked pretty good when it was just purple, but across the whole federation, you know, we're still very much a small fish in University of Auckland. It's, even though like it's a research cloud and we don't really have an SLA, we're not really fit for super production services that can't have a second of downtime and everything, we're still really reliable. I mean, that's just about 3 nines, which is really good for, we don't even have on-call really. So if something breaks at night, then unless it's something that we can easily fix, it's next business day, best effort, right? So I think this is really, really good. It shows really how stable the platform is. It shows the expertise of core services at Nectar and ARDC and how well they can actually run the core services as well. And if you're not available with like the 5 nines, I'll round up to 3 nines, so I'll just be generous. And 3 nines is kind of the standard for like a single instance cloud service, which is exactly where we need to be, right? If you're running a production service and it's got, you know, multiple databases synced across different availability zones, different geographic areas, that's not what we're kind of aiming to be, right? So I think we're pretty successful at that. So takeaways, the dashboard at Nectar, the web interface, it's still sysadmin-y, right? You've still got to know a little bit about networks and ports and TCP, UDP, and these kinds of things, and it's not suited well for researchers. We've got a lot of other solutions like virtual desktops and some automated build things that kind of abstract that away, but it's still kind of a barrier. Sharing GPUs is hard. They're really expensive. At the moment, at least at University of Auckland, we've just got PCI pass-through. So it's 1 VM, 1 or more GPUs, and GPUs are really bursty, right? They'll use it for a few hours, and then they'll be idle for a few days. They'll use it for a few hours, and it's really hard to share that. We're looking this year at going with vCPU, which is where you virtually time slice the physical GPUs. I think ARDC has implemented a solution with that in Australia, but we don't have that here yet. I've already been over offboarding, but it's absolutely critical. User support, the distributed DHD is amazing. So we give the first 2 hours of every day between 9 and 11 a.m. To DHD, to the distributed support, and then we hand off at 11, and then they give us support for the rest of the day. And right now that goes to, what time is the latest? Yeah, it'll be Perth this year, you know, when they come on board. So quite late in the evening. So it's and everyone, there's subject matter experts in different domains across different universities in Australia. And if you don't know the answer, then someone else can. It's a wonderful community. It's still difficult getting BAU funding. We're kind of like a BAU service now, and we're having you know, end-of-life hardware and these things, and it's still kind of a project model, and so you know, we get some hand-me-down hardware, and you know, we'll do a business case to kind of refresh BAU hardware, and it's not an ideal model, right? We're kind of not recognized as a first-rate player, you know, as far as running a service. OpenStack's really complicated. It's hard to hire people with OpenStack expertise, right? In most cases, it's an international recruitment, and as we all know, it's really hard recruiting right now. So that's something to keep in mind. And now, I mean, the environmental impact is a lot more important than it used to be. I don't think that needs to be expounded upon. So we're looking at a tiered approach. I'll go over this more with the talk with Tom at 220, kind of a proportional ratio of the more freedom you want to have as far as exposing services to the world, the more responsibility and scrutiny you have about keeping it patched and using good security practices. And a 3-tiered system where you get more of one, you get less of the other, it requires more of the other. We're we've got a VDS service already through the generosity of ARDC. Anyone from the University of Auckland at least can log in to the VDI dashboard and spin up a VDI. And with minimal technical knowledge, Bernard went through a great demo of that yesterday. We're going to be expanding that soon to have the VDI service run on University of Auckland hardware, which is really important for the Whisper AI transcription service. I put the heart in here for giving such a great demo yesterday, Bernard, sorry. So we've got a use case for an AI transcription using the OpenAI Whisper service, and that's hosted on-site for medical sensitive data. It's secure by default. You can only get through it through the Guacamole web interface. So you can just put your file in, take your file off. You can't share it around. You can't open ports. You can't do any of that. It's ephemeral. It discourages data from sitting around on a VM for years or something. It's automatically shelved and deleted, at a certain point. So we're looking to get the first users on in Q2, running it as a service in production 3. Secure research environment, Yvette's got a talk this afternoon. It's really, really amazing. I won't go through it in detail. I'm guessing I'm running out of time. But it's essentially, it's a different region. This is what I was obscuring before. It's a completely different region of the cloud that's completely restricted. And it only uses a couple of the most essential services and the most secure services to talk to Melbourne and the core services. And it's a completely secure and managed environment where researchers can analyze very sensitive data. That's kind of it. So with that, we, leveraging the collaborative nature of the cloud as well. We're not the first to do it, and we don't have to be the guinea pigs. QSIF has already done that, and we've been in deep talks in collaboration with QSIF, to see how they did it and to learn by their mistakes or the things that they wish they would have done better and everything. So, it just adds to the awesomeness of the model. So that's it.
Thank you. Questions for Sean?
So, Sean, for the Pawsey node that's coming on, is Nectar going to be a part of the Photonics supercomputer, or is it separate hardware?
Bernard, would you know that?
It is separate
Hardware, okay, thank you. And what about the storage? The storage at Pawsey, is that going to be a part of the Nectar node? Will you be able? So people will be able to store data at Pawsey. Okay, thank you.
We'll make Wolfgang, you're the last one.
Okay, I'll be quick, thanks. So I saw before that you said that supporting researchers is hard. So I wondered if you could expand quickly a little bit on that, where you see the key problems, and if you have some thoughts around what could be done.
Supporting researchers from like a help desk perspective, or?
I saw it on your slide. So that was one of the troubles and learnings, I think, that you said on the slide. Supporting researchers is hard.
Well, I think from a corporate model, right? So going through, for example, when we originally had the VMware service, it's a very kind of corporate help desk, and the tickets would go to like a central service department in IT that handled generic requests, and it would get hung up there because they don't know what a researcher does, or they don't know where to put it, and so there'd be a disconnect in the huge help system that's the university. And with the distributed help desk, every ticket that we come in, the people behind that ticket know that it's coming from a researcher using this platform. So it can be easily tailored from people that have expertise.
So it's an expertise problem in the end, so that people understand what researchers are doing and respond
Exactly. Yeah.
adequately.